students. How are you? I hope you all are well and fine. Now, in today's session, we are going to learn about the next chapter, that is lesson number 9, force. Let us start with the introduction. We hear the usage of this term many times in our day-to-day life. We might not know that we are using it. So, there are certain examples in our day-to-day life are opening a door, riding a bicycle, lifting an object. These are the few of the most things that we perform in our daily lives, and all these require a forces. So, what is a force? Come and sit a ball lie on the ground at rest. It is not moving. Suppose this player here wants to pass this ball to his teammate who's standing on the other side. How will he do that? He needs to meet this ball in moving the direction of his teammate. So he will kick the ball in direction of his teammate. See, he kicked this ball in the direction of his teammate. Okay. So when he kicked the ball, we say that he applied the force on the football. Okay. Yes, kick. Kick is nothing but the force he applied on the ball. Suppose that we have a desk at point A. A person wants to move his desk from point A to point B. Okay. Again, how will he do that? Here, he will push that desk towards the point B. In this case, we say that person applied a force on the desk in order to shift it. Okay. So, the push here is the force that the person applied on the desk. Similarly, when you lift some object, okay, here when you lift some object from the table, we say that you applied a force on that object. And here force is applied in the form of lifting. So force is nothing but the action such as kicking, pushing and lifting, etc. performed on objects. So there are many actions that we can perform. We have already seen few of those. So some more of them are given below. See, while riding a bicycle, we pedal it continuously to keep it in motion. So here pedaling is a force that we applied on a bicycle. Okay. Hitting the hammer on the nail is also a force which is applied on the nail. What about stopping a moving ball? Yes, even stopping the ball means we apply a force on it for getting stopped. We applied some forces to stop the ball. Opening a drawer, okay, plucking the finger or guitar, moving a piece on a chessboard. These are all some of the other actions which perform on the object. Okay. So performing these actions on object is nothing but applying force on them. Okay. Applying force on that objects. But these are the handful simply too many actions that we can perform on object, and is not possible to write each and every example or each and every one of those. But we can categorize all these actions into two basic ones. That is, we can describe all these actions under two actions, namely pushing and pulling. For example, when we open this drawer, we are simply pulling the knob. tap on the door to open it. Okay. Similarly, when we are drawing or lifting a bucket of water from the well, we are pulling the bucket towards us. Okay. So what are the actions that can be described under the pushing? See, actions such as passing the ball, hitting the hammer on the nail, etc. can be examples of the pushing at objects. Are there any actions that can be described under both pushing and pulling? Yes. Is there any actions which can be described under both? Means at a time pushing and pulling, what kind of actions are there? Yes, there are suppose in this table it is the book. You can either pull it towards to like this, and or object can be drawn away from you. Similarly, opening or shutter door can be thought of as both, that is pushing and pulling. When you open the door, you can push the door. Okay. When you close the door, you pull the door. So both the actions are doing on the same object. Okay. Pushing and pulling. So while pushing the door, you apply a force. Also, while pulling the door, you apply a force. Okay. So force is nothing but a push and pull applied on the object. Okay. Force is nothing but a push and pull applied on the objects. Now the next topic is forces are due to the interaction between the objects. Okay. Here we perform some of the actions, and in that actions we apply the force. But while applying the force on that object, how that object would be in move position, or that is that object in a motion, or we can stop the ball. So in that case, or while doing any kind of action, or while applying the force, there requires certain interaction with that object, so that the force will applied. Okay. So forces are due to the interaction between bodies or the object. What does it mean? Let's go back towards first example of this video. Here, in order to pass the ball to his classmate or the teammate, the player must move it. Okay. Here, in order to pass this ball to the teammate, okay, the player must move it. Okay, that ball should move. So that is, he must interact with the ball to move in the direction of his teammate. So that boy should interact with the ball in the direction of his teammate, so that when he interact with that ball, then and then only that ball will move towards the teammate. Okay. So that boy interacts with ball by kicking it. How it interacts? By kicking it. See, the ball and the player interact with each others. In the second example, in order to move a desk, see, in order to move a desk from object or from point A to B, he must interact with desk. Okay, So we will study more interactions in future videos. But now we all clear with basic understanding of forces. I hope you all are clear with the basic understanding what is a force. Okay, this is all about the introduction of force. Okay, so the main definition of force is a push or pull upon an object resulting from the object's interaction with another object. Okay, so this is all about the force. If any student have doubt about this, they can feel free to ask me in comment. Okay, I hope you all are clear with this term, so I will further proceed. The next topic in this next topic of this chapter is resultant force. Here are the two pictures. What you will see in this picture? See, in first picture there are three boys who pushing that table. In the second picture there are two boys who pushing that table. Now the question is arise that what is resultant force? Sometimes the force which we apply on an object is not sufficient to move that object from its place. Okay, from its place. So in such cases one needs to apply more force on that object. Okay, so in this example, a small boy cannot push a heavy table. So to push that table there requires two or more boys. Okay, so two or more boys together can push the table easily. Here each boy apply a force on the table in the same direction. See in that picture, these three boys apply the force or push the table in the same direction, that is towards the left. Okay, so from this first figure, from this first picture, we can conclude that all the forces applied on an object in the same direction results in large amount of force. Suppose force is denoted by capital F. Okay, so there are three boys who apply the force on that table. So suppose that three forces are acted over there. That means F1 means force 1, that is force which is applied by the first boy. F2 force which is applied by the second boy, and F3 the force which is applied by the third boy. So whenever all these three boys apply the force in the same direction, so in that case there occurs a large amount of force, so that heavy object or the table can move from one place to another. So in this case, whenever the force is applied in the same direction, there occurs a large amount of force. Okay, so that greater amount of force is nothing but the resultant force, means the total force, how that total force is act. Okay, so it is the sum of all the forces which acting on that object in the same direction. So you have to always remember that whenever any kind of forces acted on any object in the same direction, here same direction is important. Whenever forces are acted in the same direction, At that time, the resultant force will be the addition of that forces. Means togetherly these forces act over that object. Okay? So, if three forces acting on the table in the same direction, that is F1, F2 and F3, then the resultant force, that means F, acting on that object will be the same. That is, will be sum of these three forces. That is F1 plus F2 plus F3. Okay? See in this case. Forces, whenever applied in the same direction on an object, always add up. Okay? On the contrary, when the forces applied in opposite direction on an object, it will be the difference of these two forces. How? See. In the second example, there is a table. There are two boys. One boy push the table from left hand side and one boy push the table from right hand side. Okay, so these two boys push the table in opposite direction. They apply the force over there but in a opposite direction. So if the forces are applied in opposite direction on an object, then the resultant force will be the difference of the forces applied in opposite direction. So at that time, how much will be the total amount of force? The total force which is applied over that object, over that table by these two boys is the difference between them. Means difference means they subtract. These forces are subtract. Means suppose F1 force is applied by the one boy and F2 force is applied by the second boy. At that time, the resultant force in the opposite direction, in case of opposite direction, will be F1 minus F2. Okay, whenever force applied in the same direction, at that time force will add up. And when the force is applied in the opposite direction, at that time the force will differ. Means there occurs a difference. Okay. So the resultant force will be difference of that forces. Now there are certain examples. See here one example is there. Here the forces are applied on that object are see 60 Newton and 30 Newton. These both the forces are applied in the same direction. Whenever they are applied in the same direction, at that time these forces are added up. Means 60 plus 30 we get total, that is the resultant force 90 Newton to the right. But in case of second, see when the force of 10 Newton is applied towards left and 30 Newton towards right, that means the direction is opposite. At that time the resultant force will be the difference, that means 30 minus 10, which is 20 Newton to the right. Okay, these are the two cases where the forces are applied, means in the same direction and in the opposite direction. But there occurs one case that if these two forces, if two forces are applied on the same object, but these two forces are suppose in equal amount. Okay, suppose here in that case, see these two boys pull this vehicle. Okay, in that case one boy apply 300 Newton force towards left, second boy apply the same force towards right. So at that time, whenever the same force is applied on the object in opposite direction, at that time the force will be, resultant force will be difference between these two forces, that means the zero, because these two forces are same. Okay, so this is all about the resultant force. Now the next topic is, every force has a magnitude and a direction. Okay, we have seen simply some of the examples. In that case, we seen that some of the actions are performing, or some of the forces are applied in various directions. Okay, now in this case, what is a magnitude? See, magnitude means the amount of force. Till we study that forces are applied over the object, whatever may be the direction, okay, but we don't get any idea about what amount of force is acted over there. Okay, so the amount means the magnitude of the force. Suppose during the storm, now just we face the storm. Okay, now this, during this storm a big tree falls on the road. What happens? A single person cannot remove that whole tree from the road. Okay, so because that tree is very heavy, so what will one can do? One can do, tie a rope to the tree, and 3 to 4 peoples, not only one, 3 to 4 peoples try to pull the tree or lift the tree and to put it in a side. So, do the forces applied by the different persons added up in this case? There are 3 to 4 persons which apply the force, okay, which apply the force on that tree to pulling over there. So at that time, do the forces applied by the different persons are added up? Yes. As all the people are applying the force in the same direction, so that forces will add up and a larger resultant force will produced. Okay, so the strength of force, that is how much of force, it's called its magnitude. It's called its magnitude. So the magnitude of a force tells us the strength of the force in a numerical form. That means 20 Newton of force is applied. See, Newton, it is the major or it is the unit of force. Just like it is the just like force is measured in Newton. See the example, when you measure the milk or the water in liters, you measure the length in centimeters. Okay, so you measure the distance in kilometers. So at that time we use the unit kilometers, centimeters for measuring that. So just like that, for measuring the force, the unit is used, which is Newton, capital N. It is denoted by capital N. Okay, so 20 Newton amount of force is applied there. 10 Newton force is applied there. So this is all are the magnitude. Okay, these all are the, so the strength of force or the magnitude of the force is in the numerical form. So this is all about the concept of force. how the forces are interact and the resultant force, its magnitude and direction. In next session, we will cover the next topic, that is the effect of force and the types of forces. So, students, if anybody have the query regarding these topics, so please feel free to ask me in comments, and please do your notes from these topics. Okay? Thank you.